Section 1.2, we're going to look at a couple different graphs that we can make to display quantitative data. Okay, so the first one is something you've seen before, a dot plot. Really simple, just a dot above each location on a number line where it occurs. So this is goals scored, so every time they scored one goal, we put a dot. Every time they scored two, we put a dot. Okay, nothing you haven't seen before. Pretty simple there. Second thing is a stem plot. You might have also heard this referred to as a stem and leaf. All right, you might remember that from middle or all the way back to elementary school. Okay, things to pay attention to here is that we always order things numerically, so lowest to highest, both down the row of the stems and then when we list out the leaves. Okay, so it will look something like this. All right, so here's our data. And so our stems in this case would be the numbers that are in the tens place, and then the leaves would be the numbers in the ones place. And you do repeat numbers. So 1, 3 is for 13, and the number 13 appears 3 different times, so I put 3 3s. Okay, and then the biggest thing here, anytime you make a stem plot, is you have to add a key. So the key is just as simple as this. So for line 9 represents a female student who reported having 49 pairs of shoes. Two other things that we can do with stem plots, sometimes if we have data that are very close to each other, we can split the stems. So what that means is, like for the stem of 10, I would put 2 ones, and in the first line I would list any number from 10 to 14, and then on the second line I would list any number from 15 to 19. We can also do what's called a back-to-back stem plot if we want to compare two sets of data. And so we would do the stems in the middle and then the leaves on one side for one set of data and on the right side for the other set of data. So we'll look at what both of these things look like. So here we're going to split the stems. So for every stem that we have from 0 to 5, we're going to put 2. And like I said, these will go from 0 to 4 and then 5 to 9, 10 to 14, 15 to 19. All right, and then we're also going to do the back-to-back stem plot. So we put our split stems down the middle, and then the female numbers would go on the left and the male numbers would go on the right. Okay, we still have our key. All right, and so what this does is allows us to see kind of comparison between the two. Like there's a lot of male numbers in the lower region, whereas the females are more spread out and have a lot higher numbers of pairs of shoes. A histogram. You've probably seen this before in other classes. It is a bar chart, but each bar represents frequencies or relative frequencies, meaning the number of times that that number appeared or the percent of times that that number appeared in our data set. So here's a dot plot, which we already talked about. We can turn those same numbers into a histogram. And so like this bar right here between 1.5 and we'll say, I don't know, 1.75. All right, if we counted the number of dots that fall in that range, it's probably around 18 or 19. So that's what a histogram looks like. The way you can tell whether it's a histogram or a bar graph, first it'll probably the word frequency over here is a key, and then second, the bars are touching. That's the difference between a histogram and a bar graph just by looking at it. All right, but this is telling me how many numbers fall in that range. All right, so how do we make a histogram? First, we're going to choose the intervals that we want to use. And we have to make sure that our intervals will cover the entire data set. And our intervals also need to be the same size. So if I go from 0 to less than 5, then I can't, in the next group, go from 5 to less than 30. Like my intervals have to be the same size, and we have to make sure that they cover the entire range of the data. All right, and so then in our table, we're going to count. So what they did was from 0 to 5, they went through and counted the number of states that the percent was anywhere from 0 to 4.9. Okay, and there were 20 states in that range. Then they counted how many states were between 5 and 10. There were 13 states in that range. And this less to is important, so it means that the number 5 would be included in this second group and not up in this first group. Okay. Then, just like any graph, we need axes that are labeled. Okay, so number of states, percent of foreign-born residents, and we always need scales. Okay, I know that we went up to 30 on my percent, and then number of states, the highest frequency over here is 20, so I need to go to at least 20. And then each of these classes or groups gets a bar. Okay, so from 0 to 5, there were 20. From 5 to 10, there were 13. So this bar is up to 13. 10 to 15 was 9. So this bar goes up to 9. All right, and so on and so forth. Okay, a couple things we need to pay attention to. Don't confuse histograms and bar graphs. We already talked about the differences there. Use percents or proportions, just like we talked about before, instead of counts when you're comparing distributions with different number of observations. Okay, so if we have two graphs that we want to compare and the number in each of them is not the same, then we want to make what's called a relative frequency histogram, where instead of counts over here, we're talking about the percent. So what percent of states have 0 to 5%? What percent of states fall in that 5 to 10 range, so that we can compare the two graphs. And then, just like we talked about at the very beginning of class, just because a graph looks nice doesn't make it meaningful. Okay, so we have to make sure that we have axes labeled. We have to make sure that we choose a graph that makes sense for the data that we're trying to display. It's less important for it to look pretty and more important for it to actually give us some information. Okay, and that's it for graphs. So as we can draw those three, dot plots, sim plots, histograms, then we're good to go.